my favorite games to play late at night.
There are a lot of ways to build a clock circuit for our computer,
A lot of ways.
but we want something that's relatively flexible. We can adjust the speed. We don't want it to run too fast. We want to be able to see what's going on. And so I'm going to use the 555 timer.
We're going
This
to
is
slow
a
it down a
classic
little bit.
integrated
This
circuit here, the
octagon for the
555 timer.
Pentagon,
And that's what
Princess
this chip
Peach's
is here.
bunny.
And so you can tell pin 1 here is by the divot, and 1, 2, 3, 4, 5, 6, 7, 8. And right now I'm powering this with, this is just 5 volts coming in from a cell phone charger that I've cut into the USB cable and pulled the 5 volts out. And to power the chip, power comes in 5 volts here on pin 8 and ground to pin 1. You can actually go up to, I think, 17 volts or 16 volts or something with this chip, but 5 volts works. And to control the timing, you've got 2 resistors and a capacitor. And so the first resistor here is going from 5 volts to pin 7. This is a 1K ohm resistor. And then from pin 7 to pin 6, I've got a 100K ohm resistor. And then pin 6 is connected around to pin 2. And then from pin 2 to ground, I've got this capacitor, and this is 1 microfarad capacitor, and you can see the positive side is connected here to pin 2, so the negative side is connected to ground. You want to make sure that's in the right way. And so those resistors and the capacitor control the timing. We'll see how that works in a minute. But the output of this chip is on pin 3, and so that's just connected to this LED. The output can drive a fair amount of current, so we want to make sure we have a current limiting resistor. This is just a 220 ohm resistor.
Change in alpha with
the
delta here
LED, so we don't
to the bar. The bars we need here, 1 over C equal but not equal to the 1 atmosphere here of the ASVAB we'll be getting into the beta U
and you can see they actually give you a whole schematic of what's going on inside
what
that
the
chip,
change in field would be
we won't go through all that.
to the Mewtwo here.
But they also give you a bunch of other stuff
that's
in
going
here.
to be
One is
PSIs.
this sort of block diagram that gives you a little higher level view of what's
EV
going
here
on.
is
So
going to
you can
be
see there's
2
a couple
over,
comparators,
or 1 over
3 resistors, there's a flip-flop,
some junk
with these comparators
back to
connected
atmospheres
to,
and
and
then
there's this
into
output stage.
helium
So
or hydrogen.
this is pretty
out
interesting.
to
I don't personally
iron
like
or
the way that
whatever
this is
thing
drawn.
turns
It's
into.
kind of drawn to line up with
Which is going to
pins
get us
here.
out to the
They give
7
you a
and
different
50 cal.
version of it a little bit later on in here. This is a sort of a different view of the same
and again,
thing.
this is your week.
I don't really
we'll
like this
do
one
this
either.
equation later.
It doesn't show
This is a good one. SpaceX, right? Solid rocket fuel, liquid rocket fuel.
Okay, there's 3 things going into the flip-flop, but what?
This is going to be the
what are
housing, composites, the fittest variants of the Pentagon here.
So
for the
I drew up my
octagon.
own that I think
Preparation
explains this a little bit
line,
better.
preparation line.
And you
Which
can
one's
see,
better?
just like
And
those other
the
diagrams,
marshmallow
there's
here.
the 2 comparators.
Hydrogen
There's
to
a
fluvium.
flip-flop. It's actually an SR latch.
Tylenol to aspirin.
Describe what this thing is.
Recrystallization, right?
And
So 32
we
degrees
just kind of walk
Celsius,
through what's
the
going
headache
on
not
here.
so
So
bad.
everything inside this blue
Or
box
Fahrenheit,
here is
32
kind of what's
degrees
going on
Celsius,
inside
we're in
the timer itself. And then the green stuff that I've drawn out here is the rest of the circuit. So we can kind of go through and look at what we've got. So this 1K, this is a 1K resistor.
One day you
going
have
from
to do
5
this.
volts
Well,
to
we
pin
could just
7.
use the standard ASVAB for
And then
the
between pin 7
ASVAB and
and
just
6, that's this
clean that up a little
100K
bit because
resistor.
it's better
Here.
to have
And then you
them
can see pin
ready.
6 and 2 are connected.
Okay,
There's this little
at
green
least some
wire
basic
going around
functions
here.
in here.
And then between pin 2 and ground, we
When
have this
you're
1
running this stuff
microfarad
out, that's what this process is. This is
capacitor.
basically what he's doing. Is
And then over here we
NM.
have
I'm
our
not going
LED,
to
and
argue
this
with
is
him.
our,
Bell's equality,
220
exclusionary.
ohm,
Well, I'm
resistor
figuring
over
out how
here.
to
So this
work
is
a
our
multimeter,
circuit.
right?
And to understand how it works, we can kind of look at what's going on inside the 555 timer.
Sneaky.
So just start by looking at this path through here. You can see we've got our plus 5 volts up here. And then, of course, our ground down here is 0 volts.
We have
and then there's these 3 resistors.
a class trip
and,
with N students,
each of
Y
these
or
resistors
mouse.
Inside here is 5K. So 5K, 5K, 5K.
Okay, Y or mouse.
I think it's a complete
What is
coincidence
the
that it's a 555
percentage
timer,
of...
but anyway.
What did I have in here?
But what these do
What
is
is
these set up a
Come on. What
a
is the
voltage
percentage
divider. And
of...
so at this point here, you've got
What percentage of the class
voltage
is
between
female
0
here is
and
what I was
5
looking
volts. So
for.
that's, 1, 2/3
And we're just going to do
volts,
some
so
basic systems. If you want to think
1.67
about
volts,
those
we'll call it.
angling angles in
And
the
then at this point
space
here,
for how
we've
you
got,
analytically break down that
2/3
equation
of our 5
in
volt supply. So this
and the
is,
energy here
2/3
we're going to get
is,
into
3.33
this
volts.
charge or
And so you got
equal
this voltage
to
divider. So you got 5 volts,
in certain
you go through this
systems
resistor,
here
you're down to 3.3,
about N40. Well, you could play with the numbers you want. My point here, I kind of designed it off the ASVAB, so that was the battery. I got to use that energy. gonna be those
And what that
pins.
does is that sets up these inputs for
And then
these
so
comparators.
Jenny and
And the way the
Steffa
comparators
here
work
cutting up the pie
is
chart. I didn't tell
there's
you
a
what pie
positive
chart.
input and a
I
negative
left it
input.
wide open, and
if
I
the positive input
put it in some
is
places
above
where
the
you
negative
might want
input,
to put
then
in the
comparator switches
extra
on,
comparatively
and the output
to the
is 5
classical
volts.
spin
And if the
ratio
positive
here.
input
But
is below
if
the
that
negative
was
input,
what
then
this
the comparator
is,
switches off,
that
and
would be the
here
output.
is 0 volts.
Or at least
So
hopefully.
let's think about what
And then
happens
Dave
when
borrowing
we turn this thing on.
$2,500
Get
from the
this out of
bank.
way here for a second.
Wow.
So what happens
Field trip.
is,
Okay, we're moving.
let's
here.
assume that these inputs over here, this is all 0 volts. So we've just turned this on.
The
Stuff is 0
ratio
volts.
men to women in that area.
So we've got 0 volts
depending
coming in
on what you're
here.
looking
That is
at here.
below 1.6
The ones
volts.
and zeros
And so this comparator turns on.
start to be
And
this
so that
train A,
triggers the
train
set
B.
pin of
Doesn't
our
really matter
SR
the direction.
latch. If you don't know what an SR latch is, I've got a video on that. But
It doesn't matter the
basically, it's got a
direction.
set and a
It's
reset.
in that area.
And when the set goes high, then the output comes on.
Okay.
And when the reset goes high,
And this
then
is
the
the
output
practice
turns
page.
off.
This
And then, of
isn't
course,
the
if they go
dependent
low, then it remembers
version
its
of it.
last state. And
this
there's
is my
both
first-
the output here, and then there's
Yeah.
the inverted output here, which is always the
This
opposite of
this
our, of our
equation
output.
will be
So if we have
this
0 volts
set.
here,
Now
we
for
got 0
me,
volts here.
I
This comparator
no
will
problem.
be
I
on because
just
0 is
jump.
below
But
1.6.
you,
And
on
this
the other
comparator
hand,
will be
might have
off because
trouble
0 is
lining all this
not
up
above
in such a way
3.3. So this one's off,
that
this one's
that
on, and so the
output's
latch is
better
gonna
than
be
9
set,
volts.
which means our
Or
output
better
will
than
be,
12
will
volts.
be on.
5
so the
volts,
LED will be
24
on.
volts
So we're going to
here.
start on. So we'll do a little graph here.
Catch you on the next one.